Reaction number 2 is called acetal formation. Okay, so this reaction is we take aldehyde ketone and react with an alcohol. You can see that 2 molecules of alcohols, okay, react with an aldehyde ketone, okay, to make acetal. Okay, so 2 molecules attack the carbonyl carbon. The first attack is the first molecule will go through the from the intermediate halfway we call hemiacetal. Hemi means half, so half acetal, right? Half water basically. Okay, and after that, so the second molecule will attack. This OH comes off, and you're gonna get acetal at the end. So 2 molecules of alcohol react. All right. The common acid-catalyzed reaction. So the common acid that we add into this solution, usually sulfuric acid, usually a para-toluene sulfonic acid. Okay. We try to avoid hydrochloric acid, hydrobromic acid, hydroiodic acid, or the halide acid. Okay, only because of I think you have seen we have done reaction with HCl, HBr, Hi. Right, because iodide, bromide, chloride, they are strong nucleophile, and when we have strong nucleophile in the solution, things tend to go wrong. Okay, they can do nucleophilic attack too. That's why we use sulfuric acid, because sulfuric acid release the first proton, it turns to be hydrogen sulfate, which is very weak nucleophile. Electron resonance stabilized. We can go all the way to that, but no, not today. Okay. Anyway, now we add just small amount, catalytic amount. Okay, how much is catalytic amount, by the way? Not a lot, just a few drops of concentrated solution. Okay, so when you put this into the solution of water of alcohol, okay, so the identity of the acid, the species that you use to pronate something else, it's not this guy. Put sulfuric acid into water. Do we have sulfuric acid floating around? No, right? So we'll take water or alcohol, depends on the solvent, right? So if you use alcohol, so this is going to be alcohol. Okay. So when you put sulfuric acid or a strong acid, protonation or dissociation happen first. Okay. So the identity of the acid is that guy, hydronium ion, or the protonated version of alcohol, depends on what the solvent is. All right. Okay. Let's check it out. Okay, how this works. Okay, so hemiacetal formation. So we're gonna go from acetone. We're gonna use acetone as the our representative for alcohol and aldehyde and ketone. Okay. All right. From acetone, we're gonna go to acetal. Pass through hemiacetal first, halfway. All right. Let's get started. Okay. So the first reaction, when we add the an acid, the first step, of course, protonation. Okay. All right. That guy is highly electrophilic now. So we take the first molecule of alcohol, attack the carbonyl carbon. Okay. All right. Get to this point. I think you can guess. Look at this guy. Do you recognize that? This is a strong acid, hydronium ion. What's the pKa? Anyone here remember? Still remember? Negative 1.7. So this guy gonna this proton gotta leave. Okay. Won't survive here. So take another molecule of water, grab that proton, and now we get to halfway, hemiacetal. Okay. All right. Take hemiacetal. We're gonna go to acetal. So we need one more alcohol to react with. All right. So, all right, hemiacetal. So start with the pronation. So pronate. You can pronate either or. Okay. Got to this point. Always got this question. You can pronate either OH or OR. Right. If you pronate an OR, you just go backward. Okay. Which it exists. All these are in equilibrium. All species exist. But the goal of drawing the mechanism right now is to explain how acetone goes to this acetal. So if you want to go forward, I'm going to pronate the OH group right there. Okay, but you can pronate either or. All right, you just go backward or go forward. All right, get to this point. If you look at the acetal, so it looks like this water got the leave, right? So can I take another molecule of alcohol, attack right there, make it leave? Well, you should not. You want to guess why? You should not do that. Well, this is quaternary carbon. Remember, this kind of look like an SN2 reaction. Can you do an SN2 reaction on this carbon? No, this is too statically hindered. Okay, so do not do that. Okay, so how would you make this water leave then? Well, we're going to use the lone pair right there. Okay, from double bond, kick out that water. Here we go. All right, and once you get to this point, now this is sp2 carbon wide open, so alcohol can attack right there. Okay, this is not sp3 carbon anymore. So remember, sp2 carbon is flat. All right, so steric hindrance not come to play in here. All right. Anyway, all right. So got to this point, you might be able to recognize that this is strong acid. So depronate that. Take water, depronation, and that's acetal. Okay. All right. Summarize real quick. So this is we run this reaction under acidic condition, and in under acidic condition, look at that. All right. We have to do twice here. So we have protons in, something happened, protons out. That's the first step. Right? And we take hemiacetal, same thing. Protons in, something's happened. We have loss of leaving group. We have nucleophilic attack, followed by depronation, protons out. Okay, and just like the hydration, right, acetal formation is also in equilibrium. Okay, and in equilibrium with the acetal and the keto form, and the equilibrium favor on which side depends on the stability, right? If aldehyde is really reactive, it favors the acetal formation, the acetal form. If the ketone is more unreactive, so it stay in the keto form. Okay, and since this is in equilibrium and you want the product, you can control this equilibrium, just like Le Chatelier's principle. Okay, if you want equilibrium to go forward, add more of this, use ethanol as a solvent, and remove water at the same time. Drive equilibrium forward. In practice, this won't be on exam, of course. Yeah, this is in practice. So we set up the distillation. You can do this. Put a ketone, put the alcohol as a solvent, right? Add small amount of catalyst in here and heat it up. Okay. So as the reaction happens, if water has a low boiling point in the product, so water just come out. So as we run the reaction, water vaporize away, right? Vaporize, get out of the solution. Equilibrium go forward. Okay. All right. I've been talking for a while. Let's try on your own. Okay. Let's try on your own and then check with me on the next video.